Management webcast. I'm Christine Ball, the Executive Director of Durham Sustainability. Please note, all participants will be muted for the presentation and we'll open it up for questions at the end. For those of you who are not familiar with DSA, we're a nonprofit organization who works with businesses under our Partners in Project program to help them reduce their environmental impact. Our program provides tools to our member businesses like carbon accounting and impact assessments, and we run information sessions like this webcast today, in addition to promoting and celebrating the difference our members are making in their communities. I am pleased to introduce our speaker and a member of Durham Partners in Project Green, Mr. Paul Mertes of CircuitMeter. Paul has led the company since 2014. During his career, he has developed businesses in Canada, the United States, Europe, the Middle East, and Asia in technology and infrastructure. For the past 10 years, Paul has focused on the clean tech sector, where he served as CEO of Clean Energy, a geothermal company, and as a business advisor to the Mars Clean Tech practice. Paul has a BASc in Mechanical Engineering from the University of Waterloo and an MBA in Finance from the Schulich School of Business at York University. I'll turn it over to Paul.
Thanks very much. My name is Paul Mertes, and I'm the President and CEO of CircuitMeter. We are a North American clean tech company that is leading the way in real-time energy submetering and energy analytics. Now, today in this presentation, we will introduce the concept of forensic energy management, which we define as the detailed line-by-line, circuit-by-circuit, machine-by-machine, real-time management of electricity use. We'll review the technology that is making this advanced management approach economically feasible, and we'll go over some of the main concepts and benefits that adoption of forensic energy management methods can deliver. Driving this new feasibility is the introduction into the marketplace of low-cost, real-time, circuit-level submetering, combined with cloud-based big data energy analytics software. Today, I'm going to talk a little bit about the breakthroughs in technology, how these breakthroughs can be used to empower an evolving new best practices in energy management, and how this new capability can reduce operating costs, maximize energy efficiency, minimize carbon footprint, and then help to maintain these levels of peak efficiency. We talk about a design breakthrough. What led to this? Well, the U.S. Department of Energy estimates that an average of 30% of electrical energy is wasted in commercial and industrial facilities. For Canada and the U.S. combined, this equates to approximately $80 billion per year wasted if high-density residential buildings are included in those calculations. The objective of forensic energy management is to identify this waste and take steps to eliminate or minimize it. And in other words, it's all about advancing energy efficiency. At the heart of the new approach is the availability of granular energy data and the tools that are used to analyze this data. Now, in this context, granular to us means at the circuit level and in real time. For CircuitMeter, this means sampling current and voltage at close to 3,000 hertz, determining all the power and related variables in that period with our WebMeter's onboard processor, compressing this data for all 36 circuits, and then sending this information to the cloud via internet every 3 seconds, where it's merged with data being received from other WebMeters associated with the same end user. This live database can then be accessed by a user through his computer's web browser. And with our circuit monitoring software, a wide and growing range of advanced energy analytics and notification features are available to generate insight into a facility's energy use and provide real-time feedback regarding where and when the energy waste occurs, and to provide information about when actions are required. Now, we use the term breakthrough because this type of technology package has never been available before, but also because it comes at a significantly lower cost on a per circuit basis. This is a critical aspect of our software-driven hardware design because end users will not be able to deploy and use the technology if it doesn't promise to deliver an attractive ROI. So the fact that our technology is literally at 2 to 4% of the cost of technologies from 20 years ago and 30 years and 40 years ago is a critical part of it. And it's essentially what you see on the slide here. It's information and communications technology that's driven the change in this cost reduction. Now, with circuit meter technology, we enable the cost-effective application of a process in which the user can identify energy inefficiencies, and this as well as potential equipment failures and energy conservation measures through the analysis of historical granular electrical data. And with rapidly changing climate policies, regulations, and energy prices, this has never been more important, right the way across the full range of the commercial, the industrial, and the high-density residential industries. So we'll talk just a little bit about the hardware, but in this presentation, I want to focus really on the software, the applications, and the value and opposition. But in the slide, we show you that we show you how the actual hardware works. Now, circuit meter technology was designed from the ground up to provide an entirely new level of submetering and to enable a forensic energy management capability. The platform itself includes hardware, which measures the current and the voltage, as well as the ability to take in pulse data to include and integrate measurements for gas, water, steam, and other building services. The data, as I said, is sent to the internet, where our monitoring and analytics software provides the ability to meet the needs of entire portfolios. There are no limits. There's no additional charges for additional users. And as the design evolves and features are added, the updates become automatic. So in other words, once our hardware is installed, there's no need for the user to ever touch anything again. Now, up in the upper right-hand corner, the API integration means that in addition to our software, which is accessible through your computer, you can also pull our data into other systems, whether it's an energy dashboard system, an accounting system, an ERP system, a BA system. Any of these can pull the data in real time and then use it within their own capabilities. For CircuitMeter ourselves as a company, in terms of back office support, we train our channel partners and our end users in how the system is used, the energy analytics, and the installation with a variety of onboarding programs, system training, and reference tools, so that an online support capability is really all that's needed. Now, it's important to remember that our circuit meter platform is designed to scale without limits. Each submeter communicates with the internet interdependently, and data is merged in the cloud. This means that during the installation stage, there's no costly linking of hardware, there's no cost penalties or additional work required to coordinate data from large portfolios that are geographically separate. So we can merge data from Los Angeles with data from New York and data from Toronto, and it's at zero incremental cost. A second important feature is that our communications methodology, when we includes a secure internet connection, and this means that we do not require the host system to open a port in its firewall, and so we are IT friendly, if you will. And in situations where there is no internet connection available, a low-cost machine-to-machine cellular telephone connections are also available, so we can also deal with remote situations as well. Now, we talk about granularity, and I said we talk about it being real time, and we talked about being at the circuit level. The technology can be installed at different levels of granularity. Deployment can be made at any point in an electrical distribution system, from the main switchgear to the MCCs, the motor control centers, to individual panel level, or even at the sub-panel level. This is a choice. This choice is a matter of the energy management strategy. But the more granular deployment, the more information, the more energy intelligence that is made available for monitoring analysis. Connections to multiple panels are possible while maintaining metering accuracy, however. As long as the voltage is supplied from the same electrical panel with no transformer, separating transformer, the J-boxes can be connected to multiple breakers and give flexibility in installation and precise measurement of all circuits. The central point in this aspect of the strategy is cost versus the value of granularity. Our users today have all reported that they've discovered energy waste in areas that were not on their radar. In other words, the energy savings are in the details, and getting into this level of granularity is really new in energy management, and it's really an entirely new frontier that we're delving into with the ability to generate this low-cost data. So it's all about data. It's all about big data. It's all about the ability to process this data and generate insight. Within our software is called circuit monitoring, and within that within our system, we have the ability to monitor at 3-second frequencies real-time data on your tablet or on your phone or on your computer, so you can literally walk around in a building or on a shop floor and look at a machine and see what their electrical performance is doing in real time. The other major aspect that we bring, however, is a complete historical database at the circuit level. Now, currently we keep the 3-second data for 4 days before compressing it to a 15-minute level of granularity, which makes it easier for high-speed data manipulations and analysis. But in the first 4 days, when real-time analysis of voltage and current changes might be relevant to a situation that's occurred on the shop floor or in a mechanical room, etc., then we keep that level of granularity. Now, the real-time data gives us the ability to send email alerts or notifications when preset events occur, such as energy benchmarks being exceeded, breakdowns that cause high energy use, that type of thing. And it's been the experience of industry that unless a system a malfunction of some type is catastrophic, in other words, if the machine actually stops working, high energy use can go on for days, weeks, or even years without the end users even being aware that the situation is occurring. So this is a significant opportunity. Now we look at the sampling of software features later in the presentation, but one aspect of the software I did want to point out here is its high-speed performance. Our software has a proprietary, what we call a pivot table generator, that allows the user to filter through hundreds of millions of data points. In other words, it's a big data engine with sub 1 second response times. Now, this speed, combined with powerful graphics tools, is really what state-of-the-art energy analysts really need, and what powers the ability to go right into a building once, or a factory or facility once the hardware is installed, and do what we call a virtual energy audit. You can very quickly run a long list of tests and start to gain a general insight into a building's performance right from the comfort of your own desk. Now, in this slide, we just provide so 2 parameters to give you an idea of what is included in the database and how it's organized. On the left-hand side, the main point to take away is that This is enterprise software, and so we can merge and deal with organizations that have facilities, as I said, from coast to coast, or even in Europe or Asia. And so if you're a CFO and you want to know what your overall energy consumption is in a period to date, et cetera, you can look at that, and with a push of a button, you can break it down to a state or a province or a city. But at the same time that you have this portfolio level overall reporting and analytical capability, you also have the ability to get right down to a specific machine in a specific city on a floor. So you can look at a pump, a fan, a kind of any specific piece of production machinery in a factory. So you've got this real granularity at the same time that you have a big picture capability. Now, on the right-hand side of this slide, we list basically all of the electrical variables. So we do volts and amps, we do real power, we do apparent power, we do power factor. We also meter that the length of time that any given system is powered up, so that you can provide that data into life cycle analyses and equipment utilization and maintenance programs, etc. And in addition to that, we merge that data with an outside temperature and humidity data source. And as I mentioned earlier, with separately metered pulse-equipped meters, we can integrate water, steam, and gas and transmit that data through the web meter and also present and analyze it in the software. So what are we talking about when we talk about forensic energy management? There's a number of different aspects to this overall concept that are emerging, and I'm going to talk a little bit about each of them here. We focused initially about energy efficiency, and that really is the big one. However, the ability to analyze your real-time demand and formulate demand response and demand peak smoothing is also a big area of opportunity for saving money. Precision maintenance and keeping your equipment finely tuned and not wasting energy is another. Advanced data metering, such as electric vehicles, etc., is also possible. And in addition, an advanced form of reporting that includes greenhouse gases are all facilitated once we get into this kind of approach. So let's go back and let's just talk a little bit about conservation and continuous energy audit. I referred earlier to a virtual energy audit. When we go in initially and we can virtually energy audit an equipped building or a facility, that's where you identify the low-hanging fruit, the machines that are operating 24/7 when they're supposed to be off for 8 hours a day, the machines on a production line that are supposed to be powered down at the end of the shift that aren't. Everything that's on when in fact it shouldn't be is what we call unnecessary energy use, and we can identify that. We also identify unnecessary energy use not from mistakes that happen in control systems, but also from systems that are operated by people that are supposed to turn lights off, people that are supposed to turn off large photocopying equipment. Anything that's operated by people, we can provide whatever frequency, but perhaps weekly feedback with a line-by-line breakdown of where the energy is being used and to highlight unnecessary use. So you have this feedback used to heighten the awareness of the people on the team about where they're using energy, when they're using energy, and where the opportunities are to reduce that. And there are studies out there in the commercial relay world, at least, that suggests that as much as 30% reduction is possible simply by making this information available. So that gives you the idea of the magnitude that some of these opportunities present. Now, we can benchmark all equipment in a facility or a building so that we understand what the ideal energy consumption is, and then when it varies from that by some sort of preset threshold, which the user can set, whether it's 5% or 50% or 25%, Once we know that equipment is operating acceptably, we can move on and it's kind of a set and forget. However, if something happens, if there's a small malfunction, if a relay short circuits or something causes the energy to increase, you're going to know about it through our real-time notification systems. Similarly, perhaps not with incidents, but every piece of rotating machinery has a wear and tear and a useful lifetime. And over a period of years, the bearings are going to wear and they'll keep on operating. But what's going to happen is that the motors will draw more current, you'll use more energy, you simply won't know about it. So we're able to shine a spotlight on all of these areas of opportunity. And and similarly, in another aspect of benchmarking analysis, you can compare equipment that may be operating close or bang on historical norms, but you can compare it with new equipment that's available and perhaps use that evidence to increase the likelihood that you'll get a capital expenditure approval because the math is and the justification and the financial approval is just that much easier to make happen. So that's sort of the broad case for energy efficiency. There's unnecessary, there's inefficient, and essentially electricity is invisible. We make it visible, and it comes live on your screen, and you can generate both action items for maintenance and approvals if you need to spend money. Now, when we talk about demand response, just to be clear, we do not have control functions in CircuitMeter, but what we do is we generate the real-time data that can shine a spotlight on where or when a facility's peak energy usage, when it occurs, and what the detailed breakdown of that peak demand corresponds to, and then operations people can identify where the opportunities are to reduce it. Here in Ontario, but certainly in many states, most states, there is a demand charge as well as a consumption charge, and there's a lot of financial opportunity in peak smoothing, whether you're using a change in operations methodology, you're changing timing, you're shifting certain things to be recharged later, or you're using actual energy storage, which is a rising technology, in order to smooth your overall curve. The beginning steps are to understand what the breakdown is when it occurs, and then look for targeted reductions. I talked a little bit already about precision maintenance, but in addition to understanding when an incident actually occurs through increases in current draw, or when deterioration starts to occur, which is the beginning of a sort of either a repair or replace kind of decision, we can also add value by understanding exactly when maintenance is needed, so that we don't over maintain. Quite often we have scheduled maintenance regimes where there's a factor of safety involved because the cost of breakdown or shutdowns is too high, and that sort of leads to an over maintenance. So again, with this advanced electrical information, we can potentially generate a lot of value by moving to more of a precision type of mode. We can also identify where power factor is low. It's never been economic, really, to do power factor analysis at the circuit level. It's always been something that really reserved for these sort of entire facilities or large pieces of equipment. But we've had clients that literally had hundreds, say, of 10 horsepower motors in one particular case, operating at a sub 0.3 power factor, and really had no idea there was an issue because the operations was reliable and effective. So there's power factor is generally something that comes with the design of a facility, but we can shed a light on it and then open up other areas of opportunity for cost savings. Now the world is changing faster than any of us can keep up with, and so there's more and more advanced data metering applications coming at us every day. I mentioned electric vehicle recharging stations as one possible example, but specific manufacturing applications are coming at us every week, and actually before, in conjunction with demand management, energy storage as a way to offset peak demand. So this is a list that's just starting to grow, and we expect that it'll be a much bigger element of our business looking forward. And lastly, we have a function that changes jurisdiction by jurisdiction that turns kilowatt hours into greenhouse gas emissions numbers. This is all about reporting and reduction, uh, and it will continue to change. And the thing with having it included as an integral part of your software is it just saves people that are ultimately required to generate these kind of numbers for high-level reports. It just saves them the time. There's nothing better than being able to just push a button. Now, that's a really fast example of the half a dozen different ways that you can possibly save money uh, by enacting a forensic energy management approach. And this is just one example, and it's not a completed example, but it's based on real numbers in terms of the costs associated with it. But this is a 600,000 square foot building in Toronto that uses $2.5 million of electricity, and it just shows what's possible if we installed 55 systems, including installation for $170,000. That would be about 1,800 points. Very granular approach. If we included additional management costs to operate the system on an outsourced basis, and software costs, we've got a possibility with very small levels of savings to get a return on investment of 614% in this case, and a payback of a little over 1 year. And I'll just run quickly what this particular scenario shows. But we talked about eliminating usage. We talked about unnecessary use, finding systems operating that aren't operating, finding baseboard heaters in stairwells that are operating in the summer, and cooling air handling units in the winter that are operating. If we could eliminate in this particular building 1.3% in the first year, an additional 0.8% in the second year, and never find anything else again, that would generate a couple $100,000 over a 4-year period. If we could reduce operating hours, if we find equipment that is operating unnecessarily, which is a virtual certainty, at a little under 2% in the first year and 1% more in the next year, and never find anything else again, that's almost $300,000. And we talked about all the different ways we could save money with precision maintenance. In this scenario, we're finding a 0.5% increase, and about the same again in the second year, and again, never anything again. And a little bit of savings from equipment placement only in the second year, and some savings in demand management. In this particular case, 1.5% rising to 4% on costs in the second year, and then never anything again. These numbers add up to, by the end of 24 months, a little bit under 15% in this scenario. We talked before about the average number being 30%. So this is maybe a very efficient building, or we're only finding half of what might be in an average situation. This adds up to $1.3 million in savings over 4 years, and that's how you get this 614% or this 1-year payback. We're getting a lot of industrial applications coming to us now, where they all appear to be, as we're going into it, they all appear to be under 1-year paybacks, and that's before the subsidy programs that are available through various government programs. Now I'll come back to just to give you a sample of what the circuit monitoring software can do with some of the features. But again, we talk about high-speed energy analytics and hundreds of millions of data points in sub-1 second kind of time frames. People on this call may maybe not be old enough to remember when Google came on the scene, but at that time it was just another search engine, and people thought, well, what's the difference? But over time, people realized that I don't want to wait 10 seconds when instantaneous is what it will lead me to doing my next piece of work or my next piece of work. We've got very fast, highly responsive tools, and that will make a difference. It's our objective to be the most powerful energy analytics um, engine out there, fueled by the lowest cost data. And so we think this is critical in this new industry of forensic energy management or advanced energy management. I'll just sort of go through a few of them that we've alluded to in the past, and then we'll take a look at some of the new features that are coming out that are by and large all suggestions from our users. But again, we start with an enterprise view, and so we can look at as many buildings as we want and really get a big picture if you're a big picture person. At the same time, if you're concerned about a single building, you can break all your energy down into various parts of the same building for any kind of a time frame, and you can have the actual numbers to look at to give you the specifics if you want to delve deeper. At the same time, you can go again even further. You can get to a floor level and look at what the specifics are of each of the contributors and gain insight into what may look right or what may look wrong. Within an industrial facility, I mentioned earlier about motors and what low power factor can do to your costs, and we can focus right in at that level of granularity. And as I mentioned before, we can all generate the CO2 numbers that are available or that correspond to the kilowatt hours, again, at that level of granularity or on a building by building basis. Now, coming back to demand and peak demand, we have a heat map, for instance. Now, this particular one will show on the left. What you can see is this represents an entire month, and you can set the levels for what you consider to be a red line, what you consider to be a borderline, what you consider to be acceptable, and then the obvious functionality is that the eye is drawn to an area that that is of interest. Now, in our software, if you simply click on a little box of interest, you see on the second screen, then the actual numbers for the consumption that happened in that 15-minute time frame. These are all 15-minute time frames on that particular day. Then you have the item by item consumption, and then you understand what's really going down. So you can drill down and get the exact energy use by equipment in periods that are of concern. Another feature that we have, or other types of analyses that we include, are monthly energy use analyses. And of course, we can break these down into weekly or daily with hourly, etc. But what we're showing here is energy consumption versus outside temperature. We also have degree days, heating or cooling in our database, so you can automatically correlate that data, and you can export all this into other types of analytics engines that might be more sophisticated than ours, or in specific thermal examples. So all of this is really easy, and it's facilitated within the circuit monitoring software. I mentioned earlier briefly about government programs. Now, monitoring and targeting, M&V, metering verification, typically what they want you to do is they want you to generate a baseline, and then after you installed your meters and you change whether it's LED lighting or you change your operational habits, etc., you would likely have benefits based on the actual quantity of savings that are generated. So in this particular case, the red line, you'll see a baseline, and then you'll see underneath it the actual amount of energy consumption. The difference is the black line, which is the actual savings, and the green illustrates the magnitude cumulatively of savings that occur over a period of time. So Reporting of this nature is a very common feature of many government subsidy programs, and in fact, this is a sneak preview because this won't even be included in the circuit monitoring software until probably the end of this month. And just to go back to an earlier point, all of the updates come through the software as a service aspect of our circuit monitoring, so that when we implement a new feature, it simply is an invisible update, and users get a notification that it's there, how it's used, and you carry on. This is also something new that we're hoping that we'll have out in the Mars building by the end of the month as the first application, but there's a tremendous amount of interest in a public information portal, and there's a number of benefits here. But what we're talking about essentially is not a user interface, but like a flat screen that would go in a school lobby or an office lobby, etc., where you can show the visitors, you can show the occupants, the tenants, exactly what's going on in the building. You can focus attention on what building management is doing in terms of energy consumption. It can illustrate measures that are being taken, as well as we can change the screens occasionally and illustrate exactly what's being measured through various sort of PowerPoint animated videos, etc. So we think that this type of awareness tool is going to be very popular based on all of the inquiries we've had to date, and hopefully we'll have that out by the end of September. And I'm going to move to close so we can get into the questions here. I know that was pretty fast, but I'd like to just stop and actually read this slide, because it's a 2-year-old slide now, for 2015, but it says throughout the world, energy is being transformed from an unavoidable cost of doing business to an asset to be managed. Building owners and managers are taking control of costs in commercial, industrial, and residential buildings worldwide, empowered by tools and solutions that offer deep insight into the way energy is used in their buildings. Submeter technology and services are right at the heart of this transformation, providing real-time insight translated almost immediately into reduced operating costs. This was a Navigant report, but there's many analyses out there that all point to the same phenomenon. In New York State, the NYSERDA program for real-time energy management is subsidizing this 20 to 30% for 5 years. In Ontario, we've just seen the schools, colleges, and universities come up with a real-time energy metering program across the province. We've seen deep energy monitoring, a wide variety of names that are all basically associated with the same thing. And it comes down to what you can't manage, you can't measure. Essentially, the idea of generating low-cost energy data will fuel what is essentially just a next application of industrial engineering and cost accounting. But with the data and with the tools, we have the keys to saving money, and also to reducing greenhouse gases and contributing to a low carbon platform. Whether you're in the public sector, the private sector, whether you're in a building, a high density residential building, or whether you're in an industrial type facility or a factory. So on that basis, I would like to say, thank you for the opportunity, and I'd like to open it up for questions.
So Paul, we have 3 questions on the chat. The first question is, how do you determine ideal energy consumption?
That's a great question, and I think that there's a couple of different ways of doing it, but I also would like to preface that by saying I think that that's probably going to be an evolving practice. Our tools allow the user to start with what they're doing right now, and admittedly that may not be ideal, but it's a practical way to start. So, for instance, if you've got a dozen air handling units that are all similar. Uh, with a few clicks of a button, you could determine the average of those, and you can set that as a benchmark, if you will. Now, you can also input. You can take faceplate data, and you can input what you might consider to be, with some engineering knowledge, what you might consider to be a benchmark, and you work off that too. But ultimately, there's a great variability in how specific pieces of equipment are used, and so I think that to really use that function, you need to bring some professional engineering knowledge to the table.
Okay, the next question, do you identify unnecessary use automatically or manually?
Well, again, this requires insight, the insight of someone who's familiar with the facility. So that's why you really need to use our technology in conjunction with an energy management service firm, or if you're a large company that has professional energy management capabilities in house, then you could do it that way. But you really need to you need to be able to use the software and then go through and understand how it corresponds with a building's with the building's operations platform. So, for instance, we can very quickly show you when any kind of equipment group is operating. But if you identify that 8 of 48 fans are working 7/24 while the rest of them are shutting down at 11 o'clock at night, you need someone in a position to understand whether it's supposed to be working that way or not. So you need to bring a level of working knowledge to the table in order to move ahead with a forensic energy management approach. The software will not do it all. It's a tool.
Okay, and the last question in the chat, how do you determine baseline for M and V? And this is referring to slide 22.
Well, I think that that's a little bit more straightforward. I mean, all you really need to do is install the metering and establish what the level is, currently. Now, it depends on what the jurisdiction requires. If in fact you're going for a rebate or some type of money back from the government, because I guess some programs may require a 12-month baseline in order to account for seasonality and things like that. So I guess it depends on the end purpose, but ultimately, a baseline is some sort of average over some sort of period prior to the start of the analytical period.
Okay, and I've asked for clarification. What does 3 kilohertz granularity and data collection mean?
Well, we generate our data based our electrical data based on current transformers and a voltage sensor, and so it's about 2750 actually hertz, and so we sample at that rate, and then over a period of 3 seconds, our meter has a live processor in it, and we take each of those sample points, and then in the case of current, we actually take two readings, I should say. We take average across that 3 second period, and we also take a max, and so that we can generate two different current numbers for that.
Okay. So we've opened up the Q&A. There is a little hand on your screen now. If you click on that hand, you can ask a question over the phone lines. Otherwise, you can certainly use the chat feature as well, and I can read it out. If there's any more questions? I see one coming in now. How do you deal with no internet on site?
I'm sorry, could you repeat that?
How do you deal with having no internet on site?
Oh, well, that's an easy one actually. So we have a cellular capability, but in Canada and the United States, and it's actually quite low cost, and so we basically just use the cellular network to continue to send the energy. It works seamlessly.
Okay, I don't see any other questions coming through at the moment. We have recorded today's call, so we will be sending it out to all the attendees. If you do have questions for CircuitMeter, please feel free to get in touch with myself or any of the team here at Durham Sustainability, and we will be happy to put you in touch with the CircuitMeter team. Thank you so much, Paul. That was great content. I think that we certainly learned a lot in our office here, and I'm sure the attendees did as well. So I will let everyone go. And like I said, the recording will come out in the next couple of days, and you can certainly ask questions to us directly, and we can funnel them through. So thank you, everyone.
Thank you.